Every single time you send an email, watch a video, or even just load a web page, there's this hidden 7-step rulebook that's making it all happen. So today, we're going to pull back that curtain. We're talking about the OSI model, the unsung hero that makes our entire digital world, well, possible. I mean, it seems so obvious now, right? But just stop and think about it. How can a brand new iPhone and, I don't know, a 10-year-old Windows PC made by totally different competing companies speak the exact same digital language? Well, the answer lies in this brilliant and universal set of rules. Because before the 1970s, the digital world was basically the Wild West. Seriously, if you bought a computer from one company, you were totally locked into their ecosystem. Your machine couldn't talk to anyone else's. This whole vendor lock-in thing was a massive roadblock until a universal language was created, the OSI way. And here it is, the hero of our story. The International Organization for Standardization, or ISO, came up with the Open Systems Interconnect model. And it's basically this 7-layer framework that brought order to all that chaos. It created an open standard so that finally all our devices could communicate. The absolute best way to really get the OSI model is to just see it in action. So let's do that. We're going to follow a simple piece of data, let's say an email, as it travels down this 7-layer stack from what you see on your screen all the way down to the physical wire. All right, our journey begins at the very top with layer 7, the application layer. Now, this first layer can be a little bit confusing. It's not the app itself, like Outlook or Gmail. Instead, think of it as the part of the app that knows how to talk to the network. The moment you hit send on an email, the application layer uses a protocol like SMTP, that's the Simple Mail Transfer Protocol, to hand your message off. It's kind of like the digital post office clerk for your apps. Next up, your data gets passed down the chain to layer 6, the presentation layer. And you can think of this layer as a universal translator. It takes the data and formats it so that an email you send from a Windows PC looks absolutely perfect on a Mac. It also handles really crucial jobs like encryption, using protocols like TLS, transport layer security, to scramble your data and keep it private. From there, our data arrives at layer 5, the session layer. This guy is the conversation manager. It's the whole reason you can be streaming this explainer right now, downloading a huge file in the background, and have your email open all at the same time without all those data streams getting mixed up. It opens, manages, and closes each unique session or conversation. Okay, now we're getting into the real nuts and bolts of this journey. Down at layer 4, the transport layer, it's all about reliability. And here's an analogy for you. Imagine trying to eat a whole pizza in one single bite. It's impossible, right? This layer does the same thing for your data. It breaks big files into smaller, more manageable chunks called segments. It puts a number on each one, and then it makes sure they all arrive in the right order on the other end. Okay, so our data is all neatly segmented. Now it needs a travel plan. And that is the job of layer 3, the network layer. This is without a doubt the GPS of the internet. The network layer is where routers do their work. It looks at the final destination address, the IP address, and it calculates the absolute best possible path for your data to get there, navigating across all sorts of different networks, just like a car navigating busy streets. We are getting super close to the hardware now. The next stop on our journey is layer 2, the data link layer. Now, while the network layer is worried about the entire end-to-end trip, the data link layer is more like the local mail carrier. It doesn't care about the final destination at all. It only cares about getting the data to the very next device in the chain. And it does this using physical MAC addresses, making sure your data gets from, say, your computer to your Wi-Fi router. And finally, we've made it. We have arrived at the bottom of the stack. Welcome to layer 1, the physical layer. This is where the digital becomes physical. It's really cool. The physical layer takes all those ones and zeros and converts them into an actual physical signal. An electrical voltage for an Ethernet cable, a pulse of light for fiber optics, or a radio wave for Wi-Fi. This is where the bits literally hit the wire. So this whole process of adding labels as the data moves down the stack, it has a name. It's called encapsulation. And you can think of it like each layer is wrapping the data in a new container. So the transport layer creates a segment. Then the network layer wraps that in a packet. And finally, the data link layer adds its own header and trailer to create a frame, fully addressed and ready to ship. Okay, here's a quick pro tip for you. We tend to call everything a packet, right? But that's technically only correct at layer 3. The proper name for the data unit actually changes at each layer. At the top, it's just data. Layer 4 has segments, layer 3 has packets, layer 2 has frames, and layer 1 has a bit stream. Using the right term just shows you really know your stuff. So why does all of this actually matter in the real world? Well, one word: troubleshooting. When your internet is down, tech support is basically using this model. They always start at the bottom. Is the cable plugged in? That's layer 1. Do you see a blinking link light? That's layer 2. Can we get an IP address? That's layer 3. It's a perfectly logical checklist to find the source of pretty much any problem. Of course, to use it, you have to actually remember the layers first. So here's a classic mnemonic device to remember them from top to bottom. From layer 7 to 1, all people seem to need data processing. That's application, presentation, session, transport, network, data link, and physical. Or if you prefer to work your way from the bottom up, which a lot of network engineers do, there's my personal favorite. Please do not throw sausage pizza away. It's pretty memorable, though it does make you wonder what kind of sausage is on that pizza. Hey, whatever works for you. So there you have it. That's the OSI model. It is the invisible framework that's governing every single thing we do online. From just a simple click to a massive download, this 7-layer journey is happening billions of times a second all across the globe. It's the silent, perfectly organized dance that makes our chaotic, interconnected world possible. So next time you go online, see if you can picture that journey happening in the background.